Imagine a giant metal tube, 200 tons, lifting into the sky. No magic, no rockets, just air. But how? How does air, invisible, weightless, generate enough force to lift an airplane off the ground? This question puzzled humanity for centuries. Even today, most people will say it's something to do with the shape of the wing. And yes, that's the part of the answer, but not the whole answer. Because the real reasons plane fly is hiding deep inside the air itself. Welcome to the hidden physics behind the flight, beyond Bernoulli. Before we go deeper, we need to answer one thing. What exactly is lift? Lift is the force that pushes an airplane upward, the opposite of gravity. To fly, an aircraft must generate more lift than its own weight. But here's the twist, air isn't pushing the plane up from below like a spring. The plane is actually pulling itself through the air in a way that makes the air push it upward. And it all starts with the wing. Airplane wings aren't flat, they are curved on the top and flatter on the bottom. This shape is called an airfoil. As the plane moves forward, air hits the wing and splits. Some goes over and some goes under. Now watch this closely. The air over the top speeds up as it flows over the curved surface. Faster air means less pressure, and that's the rule of fluid dynamics. So the pressure above the wing drops while the pressure below stays higher. And just like that, the wing is pushed upward. This is the basic idea behind lift, and it's often explained using something called Bernoulli's principle. So, what is Bernoulli's principle? It's a physics law that explains how pressure changes when a fluid speeds up. It says that in a moving fluid like air, the faster the fluid moves, the lower the pressure is exerts. You can see in this equation P plus 1 by 2 rho V square plus rho GH is equal to constant. As velocity V increases, pressure P must decreases to keep the total energy constant. Let's leave the smooth airflow behind for a moment and zoom all the way in. What is air really? It's not a smooth flowing substance. It's a chaotic swarm of billions of molecules, mostly nitrogen and oxygen, flying in every direction at hundreds of meters per second. Pressure isn't some magic field. It's the result of those molecules slamming into surfaces. The more frequent and forceful the collisions, the higher the pressure. Now, imagine an airplane wing slicing through that chaos. As air flows over the curved top, it speeds up. But here is what that actually means. The individual air molecules are now moving faster in a more focused direction, mostly forward, not bouncing around as randomly. Think of it like this. Imagine a crowd of people. When they are walking slowly in all directions, they bump into walls often. But when they all sprint forward in one direction, they hit the wall less frequently. The same thing happens here. Above the wing, the air molecules are moving faster and more directionally, so they collide with the wing surface less often and with less sideway pressures. That drop in molecular collisions is what we measure as low pressure. It's not just about speed, it's about how molecules behave when they speed up. This is the hidden mechanism behind Bernoulli's principle. Not magic, not suction, just less impact from fewer collisions. Fewer collisions above, more collisions below. That's lift. Not just a pressure difference, but a momentum imbalance. An atomic level tug of war between the wing and the air. The real truth is this, flight is not magic, it's a molecules in motion, obeying physics one collision at a time.